アルプス処理水の海洋放出については、大きな廃炉の中の過程の一つとして大きな節目、着実な前進というふうに考えています。私どもとしては、よりリスクの高い燃料デブリや使用済み燃料の取り出し、安全な保管といったところに今後シフトしていくということになろうかと思います。
On August 24th, Japan initiated the discharge of radioactive water waste from the damaged Fukushima nuclear facility into the Pacific Ocean due to nearly full capacity of storage tanks. This action has stirred controversy, leaving China to swiftly impose a comprehensive ban on all aquatic imports from Japan. The accumulation of the water waste issue has persisted since the Fukushima plant was hit by a tsunami in 2011. Jim Smith, professor of environmental science in the School of the Environment, Geography, and Geosciences at the University of Portsmouth, joins me to discuss the science and what we should know about the radioactive water waste. Join us as we get Rebelliously Curious. Jim, thank you for joining me on Rebelliously Curious today. So this is a very long title. You are the professor of environmental science in the School of the Environment, Geography, and Geosciences at the University of Portsmouth.
It's a bit of a mouthful. Yeah.
It is. Thank you for joining me today.
Pleasure.
So I want to talk a little bit about the Fukushima's nuclear power plant that ended up, unfortunately, we know in the earlier tsunami, I believe in 2011, and ended up being affected by it. But now we're seeing that they're now disposing of this water waste that's radioactive. Can we start just about the impact, first of all, from that initial water waste that will be going into the Pacific Ocean? And I believe they say that from what I read, it's 1,000 tanks, which is over 500 Olympic stadiums, pool-sized stadiums that they're filling up, which is a lot of water. Can we start off can we just start off briefly about what those environmental impacts are starting now and what that's looking like?
So there's all these tanks. So if you look at a map of or an aerial photograph of the Fukushima site, you'll just see it's full up with these giant tanks, and they've been storing this slightly radioactive wastewater since about 2012. And the plan is, they've begun discharging that to the Pacific Ocean. It's treated wastewater, so it means that almost all of the radioactivity has been removed from it. But what they can't remove is a thing called tritium. And tritium is a radioactive form of hydrogen. And what happens in nuclear reactors around the world is that a very tiny proportion of the water molecules passing through the reactor in their cooling get turned from H2O, which we all know, to a thing called HTO. So that's where one of the hydrogens in the water molecule has been replaced by the radioactive form of hydrogen, which is tritium, and we call it tritiated water. And because it's in chemistry, it's exactly the same as normal water, so it behaves exactly the same way, and that's why it's almost impossible to strip out of the wastewater, because there's no chemical difference between the radioactive form of the water and the much greater mass of ordinary water. So just to give you a perspective on that, in that 1.3 million tons of wastewater, there's about 3 grams of tritium. So it's really a tiny fraction. But the numbers, when we quote them in amounts of radioactivity, sound quite high. So what nuclear sites do around the world, and have been doing for decades, is to release that treated wastewater into a river, a lake, or the ocean. And as an environmental scientist, I've studied the Chernobyl accident since 1990, and then the Fukushima accident since 2011. And And I don't find that a problem. And that may seem strange from an environmental scientist, but actually, I think the impact on the Pacific Ocean and on seafood consumers will be so small that we won't be able to measure it.
Is there anything in the past that would be similar to something like this? Like you said that the plants are consistently, releasing this, but is there anything else that's similar of an impact that maybe not is spoken about in the media that would, or even something that would have a greater impact right now that's not spoken about?
Well, yes. I mean, in the UK, there's a nuclear site called Sellafield where we do our fuel reprocessing and waste storage. And over decades, they've released much more radioactivity into the Irish Sea between the UK and Ireland than this Fukushima release will do. So the tritium, currently the tritium releases from Sellafield are about something like 8 times higher than the Fukushima release will be. There's a nuclear site in China that's emitting at 3 to 4 times the amount of the Fukushima release. There's one in France, in northern France, a reprocessing site called Le Hague, which emits about 450 times more tritiated water into the English Channel than this Fukushima release will do. And this isn't, well, the Le Hague one is probably the biggest in the world, but this is happening all over the world at much greater amounts than the Fukushima release will be.
Okay, that's positive. I think that there are some misconceptions because I've been reading multiple different perspectives, and we're seeing that this is potentially becoming political, or it is political because of China putting the ban recently on other exports when it comes to fish from Japan. Do you see this more as a political play than an environmental play at this point in time?
Yeah, I'm not a politician, but it certainly isn't based on science. So there's no scientific evidence that I've seen that suggests that this is somehow going to be dangerous either for the consumers of seafood in that local area or the marine organisms themselves. There have been various studies of where the radioactivity will go, and it's not just we tend to focus on tritiated water, but there are trace amounts of other radio elements because the treatment process isn't 100% perfect, but it does reduce those other elements to really, really, really low levels. And so when you account for those and you account for the tritium, the radiation doses to people who are high seafood consumers from that local area are more than 1,000 times lower than what we all get from natural radiation. So we measure radiation dose in a thing called a microsievert. So the maximum estimate is less than 1 microsievert of dose per year to high seafood consumers from this area. And that compares with 2,400 microsieverts that we all get every year from natural radiation, like cosmic rays, radiation in the food that we eat, in our bodies, and in the ground around us. And natural radiation doses can vary very widely. So millions of people worldwide get natural radiation doses of 10,000 microsieverts per year. And so really this doesn't even register in terms of risk to people's health. We've also studied environmental impacts of radiation in the environment. I've studied the Chernobyl accident for a long time, and in particular, we've looked at lakes around the Chernobyl site, including the cooling pond of the reactor that provided the cooling water. And we haven't really seen, and these are thousands of times more contaminated than the Pacific will be from this Fukushima release. And we haven't really seen significant ecosystem impacts. So we looked at invertebrates, so the little insects that live in the sediments of these lakes. And we saw the same or higher diversity and abundance of aquatic invertebrates in the most contaminated lakes at Chernobyl compared to other lakes in the region. We also looked at various health endpoints of the invertebrates themselves and their development and their DNA, and we couldn't find any significant impacts of radiation. We studied fish, and we studied 2 species of fish, perch and roach, and we think in perch that we found a subtle impact of radiation on reproduction, but the fish are still reproducing, their health indices are fine, their diversity is fine. So even in the lakes around Chernobyl, we don't see significant impacts.
Interesting. I actually thought that you would say the opposite, to be honest. I thought that there would be more of an environmental impact. And when I was reading that there wasn't as much, I was actually surprised. But now I want to look at both from land to sea. We see that in the Manhattan Project, obviously in the early 1950s or later 40s, sorry, I should say, when the Manhattan Project was going on, we noticed that there's still nuclear fallout that's affecting areas, within the Uinta Basin and within Nevada that are still, to a degree, and people are lobbying for this to have reparations paid because humans are getting affected by it. And that's, so long ago. They're saying that the nuclear fallout, would be over 100 years. So how is that different, if I can ask you, from land to sea then?
Well, that's quite a big question. I mean, there was atmospheric nuclear weapons testing. I mean, not just the Manhattan Project, but subsequently by the US, Soviet Union, China, the UK, France. That was done up until 1963, I think the Atmospheric Test Ban Treaty came into force. And in that time, there was radioactivity spread around mainly the Northern Hemisphere. And that included tritium, of course. And there's much more tritium from atmospheric nuclear weapons testing in the Pacific than there will be from the Fukushima release. Much, much, much more. So there was iodine, cesium, strontium, and I mean the radiation doses from those have been very well monitored worldwide, and there's a series of UN reports on the doses that people got, particularly in the Northern Hemisphere, and they are, I would say, they're not insignificant, but they're low. And so I can't, without going back to the reports, I can't give you off the top of my head what the doses were, but they weren't significant compared to natural radiation.
Interesting.
So they were much lower than natural radiation, but much more significant, of course, than this Fukushima release will be. Now, whether there are health effects from that, that's a complicated question. We assume for radiation protection purposes that every additional dose of radiation, no matter how small, can potentially lead to a cancer in later life. It's just that as the dose goes down, as with many things, as the dose goes down, the risk goes down. And so it's quite, you can attribute a very significant number of deaths worldwide to those atmospheric nuclear weapons testing. If you take that hypothesis, in the same way as we estimate deaths from air pollution, which of course are much, much more significant. So the World Health Organization estimates millions of deaths worldwide from air pollution. But you can get, and I don't want to give a figure because I will probably get it wrong, but I'm guessing in the hundreds of thousands of early deaths from those atmospheric weapons testing. But of course, there are billions of people on Earth, and the individual dose is very, very low, and the individual risk is very low, and much less than natural radiation, and much less actually than air pollution.
There's no way of cleaning this up.
Won't be affected, very quickly. And I haven't done the modeling, but looking at models that have been done, very quickly it'll become undetectable.
Oh wow! Okay.
More or less. So there's a no fishing zone of about. So the pipeline that discharging the water goes out about 1 kilometer from the shore, and then there's a no fishing zone up to about 1.5 kilometers. Away, and then north and south another 1.5 kilometers. So there's a box where people can't fish. I think outside that it will very quickly become undetectable against the background natural and weapons testing tritium in the Pacific. And that seems to be what the initial Japanese measurements are showing at the moment. But we'll see. And I would be very surprised if it was detectable more than a few kilometers away from the pipeline.
Yeah, and I wasn't sure this is their first initial release, but I think this is their only release, or will they be, continually?
Well, this is going on. They're being very cautious, I would say. So I would, as a scientist, I would have said, just do it much quicker and do it in a year or two. Yeah, because that's what everybody else does. That's what we do in Britain. But I understand that that there are very strong public sensitivities over this, and the fishing community are very sensitive. And so the Japanese took the decision to do it over 30 years. So this is going to be a really gradual process over a long period of time. And that's why it'll be very, we can, from Le Hague in France, we can detect the tritium in the English Channel, but I think we'll find it very difficult to detect the tritium from this release. And of course, it'll make its way around the world because that's what water does, but it will be so dilute that it won't have any significant health effect.
That's good to hear. That makes me feel more positive, obviously, about consuming seafood or anything else within those regions, and then obviously within our own waters.
Yeah,
there was
just to put it in context. I mean, we tend to forget that we focus on this Fukushima release because of the drama of the accident and the terrible things that happened at the time of the accident. And it seems, when you look at those 800 tanks filled with radioactive wastewater, it looks scary, but the real things that matter for our health are our diet, and eating seafood is a benefit. What we eat, whether we exercise, whether we're a bit overweight or not, all of these have much bigger effects on our health than this tiny, tiny radiation dose from Fukushima. And the same is true of the ecosystem. There are real environmental problems in the Pacific. The climate change is changing and habitats all over the Pacific. There's raw and treated sewage going into the Pacific from all countries. There's overfishing, there's plastic pollution. All these things have a much bigger impact on the Pacific ecosystem than this, what I would say, really insignificant release of slightly radioactive water.
It's a really great way of putting it into perspective, because that makes sense. We also look at the Deep Horizon Gulf of Mexico oil spill that was happening. I forget what year that was. I'd have to double check again. But how is that in comparison to something like this? That had such a major effect on wildlife and everything around it. And then also, do you know where we are today with that oil spill and how it's affecting the marine life?
I'm not an expert on the Deepwater Horizon, but certainly the initial ecosystem impact was much greater than this Fukushima release will have, much, much greater.
So then where do we go from here when we're looking at, even from media's perspective, we're talking and focusing so much on the Fukushima spill, and then you're also speaking about other things that we need to be more mindful of. How do we shed light on those aspects? And then, what do we do next to, hopefully create a solution?
Yeah. I mean, just to give another perspective, so the water, when it comes out the pipeline, it's diluted 100 times, and it'll have 1,500 becquerels per liter of tritium in. And so we measure radioactivity in becquerels. The World Health Organization drinking water limit for tritium is 10,000 becquerels per liter, so 10 times higher. So in theory, you could drink the water that's coming out of this pipeline at Fukushima. And that's one of the reasons why I think it's not at all significant. And I think what makes me sad is I think that we misunderstand risks of nuclear. And I'm pro-nuclear as an environmental scientist, because I think it's one of the few weapons we have against climate change. And even having studied Chernobyl for 30 years, I feel like the risks don't warrant the attention that they get. And consistently, when people are asked about risks of nuclear, they consistently put them much, much higher than scientists in the field do. And I think that, whether you agree with nuclear power or not, I think we have to have a grown-up debate about it. And that debate has to be based on the science of risk and an understanding that environmentally, nuclear doesn't present a risk. Let's set aside humans for a moment, but our experience from Chernobyl is that the ecology of the Chernobyl exclusion zone is much better than it was before the accident. Not because the radiation is good for animals. We do think there are some effects in the hotspots, but the effect of human habitation, of hunting, fishing, forestry, agriculture, that's much, much worse. And so we now see a thriving aquatic and terrestrial ecosystem at Chernobyl because the people aren't there. And so I think we need to accept that nuclear is a potential risk because not because it really gives a real health danger to people, but the impact of a nuclear accident on people having to leave their homes, the fear of radiation, the huge economic impact of the cleanup, which I think is much greater than the direct health impacts of the radiation. That is serious. But if we're going to make sensible decisions going forward about what energy we use to combat climate change, what the few CO2-free sources of energy that we have at the moment, and nuclear is one of the most important, and we shouldn't throw it out because we're scared of a bit of radiation, I think, because we shouldn't be.
Do you think then that protesters, and we look at, Greenpeace and other organizations, are just lobbying on behalf of this then without the actual data? Because they're saying different things than I'm reading here, compared to then obviously what the protesters are. And I can see protesters might have some lack of knowledge based on specific science, and they're also fighting to protect their own industry, the fishing industry. I can see that in Japan. But do you feel that Greenpeace is just using this as a lobby technique rather than, getting to the science of it? Because what I'm hearing, what you're saying, is that there's really great science around, obviously, Chernobyl from past, where ecosystems are still thriving.
Yes. I think the fishermen, I can understand why they're protesting. I think that they understand the science and they realize that this isn't a real risk. But they know that this is damaging their industry, and the experience from the 2011 accident has shown that. And so I understand that. But I think that other people who are against it, I don't see the evidence. I've looked in the Greenpeace reports and they talk about things like DNA damage and tritium being radioactive and all this, but I don't see the evidence that it's a significant risk. And on the other hand, I see decades of reports, of scientific papers, which show that it isn't a significant risk. And I would very much like if Greenpeace would, debate the science, but I don't see it. I don't see the science in what they're producing. And I find that frustrating. They're an anti-nuclear lobby group and they're very effective at it. But I would like them to engage much more in the science.
Right. I would agree with you on that. And then obviously looking at the political repercussions that are happening. I think there's more repercussions on the economy for Japan by China creating bans, because I believe it's like almost 40 to 50% of exports that go from Japan to China based on, I don't if it's food or other exports, but it's a fair amount. And now China putting that ban on that is going to affect their economy more than, I would say, environmentally, from what I'm hearing.
Yes, I don't see any basis in science for the bans on Japanese seafood or anything else.
So where do we go from here then? Are there solutions? Are there other ways outside of using, putting things into the Pacific Ocean or into our waterways? Are there other ways that we can,
No,
unfortunately, no?
It's tricky. I think we have to pollute, unfortunately, to maintain our lifestyles and to maintain a world. At the moment, we have to pollute. to maintain a world with, is it 8 billion people? I can't remember the last count.
Right.
And it's going up. And there's no form of energy generation that doesn't cause pollution. And in fact, I would argue that nuclear is the least polluting of all energy generation sources because it has a closed fuel cycle. The storage is very complicated, but it can be done. And when it's done, the radiation doses from waste stores will be incredibly small. At the same time, we haven't solved recycling of solar panels. We haven't solved wind turbine, all these things. And I'm very much in favor of renewable energy generation, but they have an impact as well. There's mines all over the world that are producing the metals we need for the renewable energy revolution, and they're causing pollution, they're causing human suffering. There's no simple answers, and this wastewater release from Fukushima just doesn't even, to me, register on the scale of environmental problems. There are alternatives. You could keep storing it, so you could keep building tanks.
That's scary.
But yeah, well, it's not the best option to me because, you can have, if you've got a tank, it can leak. You can have a typhoon or a tsunami that will cause a leak and an uncontrolled release. The Japanese need to get on with decommissioning the reactors at Fukushima, and all those giant tanks are just getting in the way. Other options that have been tried after the 3 Mile Island accident in the US, the tritiated water was evaporated, but a subsequent study found that the doses to people were still very low because it's tritium and it's not super strongly radioactive. The doses were still low, but they were about 300 times higher than they would have been if the water had been discharged to the local river. So, there are other options, but to me, this release to the ocean is the best option and will have negligible impact.
That's awesome, Jim. Thank you so much for your time today. And
Pleasure.
as I say to all of my guests, thank you for being rebelliously curious with me.
Thank you.